Okay, today we're going to be talking about comparing linear functions, in this case applying to graphs and equations. So when you're comparing linear functions, really what you're comparing is the slope and the y-intercept of those functions. So for our first function, function A, we want to figure out what the slope and the y-intercept are. Now, when we look down here, we know all it's asking about is the y-intercept. Well, let's start out by just figuring out what the slope and the y-intercept of both are. Okay, so with an equation, it's really easy because this equation is written in y equals mx plus b form, where m, the coefficient of x, is the slope, and b is your y-intercept. So for function a, my slope, right? My slope is 5, right? 5 right there. And my y-intercept is -1, okay? My y-intercept is -1, all right? Now for function b, when you're looking at a graph, okay, the y-intercept is just where the line crosses the y-axis. So if I zoom in here, I can see that this crosses the y-axis at -4. So that means my y-intercept is -4. Now, in order to find the slope of a line, which we've been going over, in order to find the slope of a line, I need to pick 2 points. I already have one, which is my y-intercept, and I need to pick a second point. And remember, they need to go through the corner of a grid, right? They need to be traveling through the corner of one of your units. So I have one right here, okay? After I pick my 2 points, I draw a right triangle. Okay, there's my right triangle, and I count my rise and my run. 1, 2, 3, 4, and my run is 1. So I have a rise of 4 and a run of 1. Now this line is going up from left to right, so I know it's going to have a positive slope. I write my slope as my rise over run. In this case, my rise was 4 and my run was 1. And that just simplifies to be 4 over 1. Because a fraction is just division, we can simplify that to just be 4. Okay. Now our question asks us, which statement is true? The y-intercept of function A is greater than the y-intercept of function B. The y-intercept of function A is less than the y-intercept of function B. Now we have -1, okay? Function A, okay? Function A, right? Function A has a y-intercept of -1, and function B has a y-intercept of -4. Which one is greater? Okay, greater. When you are comparing two negative numbers, the one that is closer to 0 is greater. Okay, so in this case, function A, -1, right? That's closer to 0. It is the greater value. And so we can answer that the y-intercept of function A is greater than the y-intercept of function B. Okay, now let's move on to another problem here. Let's see. Okay, this one is asking us to compare the slopes, but we're still going to do the same thing we did last time. Okay, all right, my slope here is 5, and my y-intercept is +3. Sweet. Very easy to find it from an equation. I was going to do the equation first just because it's so easy to get done. So equation out of the way. We know the slope, we know the y-intercept. Now we're going to look at the second one. We have a y-intercept right there of 1. Y-intercept of +1. Okay. And we're going to find a second point here. There's one right there going through the corner of my grid. I draw my right triangle. My rise is 1, 2, 3. My run is 1. Remember, we write our slope as rise over run. So this is going to be 3 over 1, or just 3. So we look at function A. Okay, my slopes, we're comparing our slopes. Function A has a slope of 3, and function B has a slope of 5. Which one's greater? Which one would you rather have? If I said you could have $3 or $5, which would you rather have? Obviously the $5. 5 is greater. 5 is the greater thing to have. 5 is the greater value. So we can write that the slope of function B is greater than function A, or in this case it says the slope of function A is less than the slope of function B. Okay? Pretty straightforward. Okay? Pretty straightforward. All right, this is where it gets a little bit more complicated. It says the y value of function A when x equals -3 is greater than the y value of function B when x equals -3. So all we have to do here is figure out what is y when x is -3. So all that's going to involve is us plugging in -3 into our equation. That's how we're going to figure out what y is when x is -3. So I plug it in, I substitute it in for x. When I substitute something, that means it goes away and I replace it with the other thing. Right? When there's a substitute teacher, I am gone and the teacher is here. Okay? They replace me. So I'm replacing this x with -3. Right? And then I need to put my +2 there. So y equals 2 times -3, which is -6. Right? Plus 2, we'll bring that 2 down. And -6 plus 2 is -4. Okay? -6 plus 2 is -4. All right? So now with our graph, this is where maybe it can get a little bit more tricky for you guys. All we're going to do, okay, is figure out what y is when x is -3. So all I have to do with that is I go out here to -3 and I see where it touches the line when x is -3. And when x is -3, okay, when x is -3, y is -9. So, is the y value for function A when x is -3 greater than the y value of function B, or is it less than, right? In this case, right, y is -4, y is -4 when x is -3, and for function B, y is -9 when x is -3. So, -4 is the one that is closer to 0. We're comparing two negative numbers closer to 0. So, -4 is greater than -9, which means that the y value of function A when x equals -3 is greater than the y value of function B when x is -3. Okay? All right, moving right along. Again, we're going to be comparing slopes. All right? Now we've done enough of these problems now that let's just identify the slopes. If we know that what we're comparing is the slopes, let's just identify those. The slope here, okay, that's the coefficient of x, is 2/5. And then the slope here, we need to pick 2 points. Pick those two, just to make it a little bit more of a challenge. We're going to have to simplify this. Up, 1, 2, that's my rise. My run is 1, 2, 3, 4. So my slope, again, is my rise over run. In this case, 2/4, which simplifies to be 1/2. We can divide the top and bottom by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. Okay, so we have 1/2 and 2/5. Now, when we compare things, it's a lot easier to compare things when they are the same, when they are similar, right? it's hard to compare two things that are very different, right? But in this case, we have two fractions. If you have trouble figuring out which fraction is bigger, then you want to make them equivalent fractions, right? We want to make them have common denominators, because if they have common denominators, we just need to see which numerator is bigger, right? That's the easiest way to compare. So we have 2/5, we have 1/2. So let's list out their common factors for their denominators. We have 5, 10, 15, 20, 2, 4, 6, 8, 10. There we go, right there. 10 is going to be my common factor, right? So if I want to end up getting 210, right, I have to multiply by 2, okay? So that means I'm going to multiply this top number by 2. So 4 over 10 is the same as 2 over 5. Now in order to get from 2 to 10, I have to multiply by 5. Okay? So if I have to multiply the denominator by 5, I also have to multiply the numerator by 5 in order to make it an equivalent fraction. So I have 4 over 10 and 5 over 10. Okay? So which one's bigger, 4 over 10 or 5 over 10? That is going to be 5 over 10, which belongs to function b. Function b. So the slope of function b is greater, right? Which is the same thing as saying the slope of function a is less than the slope of function b. So right there, we're just comparing two fractions. Okay. All right, last one. 2/5 for the slope of function a, since we know this question is asking about slope. And then we will zoom in here. 1 and 2, which is 1/2. Well, guess what? This is 2/5 and 1/2. Our previous problem was also 2/5 and 1/2. So now we should know that 1/2 is greater than 2/5, which makes this easier to know that the slope of function a is less than the slope of function b. And that is how we are able to compare linear functions. We can compare what their slopes are, we can compare what their y-intercepts are, and we can compare what their y values are when x is a given number.